Hey everyone, and welcome back to this class, the Numpy stack in Python. In this lecture, we are going to talk about matrix products. What's interesting about matrix products when you learn linear algebra is that you usually learn about what's called matrix multiplication. Matrix multiplication has a special requirement, and that's that the inner dimensions of the two matrices you are multiplying must match. So if I have a matrix A of size 2 by 3 and another matrix B of size 3 by 3, then I am allowed to multiply AB since the inner dimension is 3. I cannot, however, multiply BA since the inner dimension on the left is 3 and the inner dimension on the right is 2. You might ask why we have this requirement when we multiply matrices. Let's look at the definition of matrix multiplication. So the ijth entry of C is the sum of the multiplication of all the corresponding elements from the ith row of A and the jth column of B. In other words, Cij is the dot product of the ith row of A and the jth column of B. Because of this, we actually use the dot function in Numpy, and that does what you recognize as matrix multiplication. A very natural thing to want to do, both in math and in computing, is element by element multiplication. For vectors, we already saw that an asterisk operation does this. As you can imagine, for 2D arrays, the asterisk also does element-wise multiplication. That means when you use the asterisk on multi-dimensional arrays, both of them have to be the exact same size. This might strike you as a bit odd, because in other languages, the asterisk actually does mean real matrix multiplication. So you just have to remember that in Numpy, the asterisk means element by element multiplication, and the dot means matrix multiplication. Another thing that's odd when we're writing down mathematical equations is that there isn't even a well-defined symbol for element-wise multiplication. Sometimes researchers use a circle with a dot inside it. Sometimes they use a circle with an X inside it. But there doesn't seem to be a standard way of writing it in math, even though it shows up quite a bit in machine learning due to the way gradients work.